This time we will discuss about non-homogeneous equations using undetermined coefficients. Now to solve non-homogeneous differential equations, we have y, we will write here y, which is equivalent to y sub c plus y. We will be using this variable y sub p, wherein our y sub c is what we call as the complementary function. Complementary function. And then for our y sub p, these are our particular solution. Okay, so let's have our example to solve undetermined coefficient. So let's say example number 1, solve the equation, the differential equation, which is 2y prime, 2y double prime and minus y prime minus y, which is equivalent to t squared plus 2t plus 5. Now to solve this equation, we have different ways, steps to follow. So I will write here step A. We have to write the auxiliary equation of this part. So we have 2m squared, that is the second derivative, minus m, that is the first derivative, minus 1, which equate this one into 0. We will just focus only to this part, that is our step A, and then we're going to find the value of its root. So this one, we will have our synthetic division. We have 2, negative 1, negative 1, and then we're going to find its root. Let's say this one is negative 1, so we will try negative 1. 2, bring down 2, 2 times negative 1, that is negative 2. When we add this one, that is negative 3. Negative 3 times negative 1 is positive 3. But then if you add this one, the equivalent here is not equal to 0. So probably negative 1 is not a factor of this equation. So we will change our factor here. Okay, so we will change. So negative 1 is not a factor. So this time we will make use of 1. So 2, bring down 2. 2 times 1, that is 2. When we add this one, negative 1 plus 2, that is positive 1. 1 times 1, that is positive 1. So when we add negative 1 and positive 1, that is equivalent to 0. Thus, our 1 factor is equivalent to this one, which is equivalent to 1. Now for this case, this is now 2m plus 1 equals 0. Therefore, we can find the value of m here as m is equivalent to negative 1/2. So we have two values of m. Let's say this is m sub 1 and then this one is m sub 2. Now, once we determine our roots, so we have now our y sub c, complementary function y sub c, which is equivalent to, now this is an auxiliary equation wherein we have here our distinct roots, 1 and negative 1/2. So we will write here c sub 1 e raised to 1 t. So we have here t. And then plus c sub 2 e raised to negative 1/2 t. So negative 1/2 t. Okay, so this is our complementary function, y sub c. This time, we will find our particular solution, y sub p. Now, we will focus to find this y sub p, we will focus this part. Okay, let's say step B. Step B, we have t squared plus 2t plus 5. So we have here plus 5. And then we take the derivative of this part. So take the derivative, you have here 2t plus 2. And then again take the derivative, that is 2. So if you have noticed this one, take the derivative of 2, that is 0. So if you have noticed this one, we have here, we will form a undetermined coefficient, which we say a, and then this is t squared plus b times t plus c. Notice this part, t squared, so we have here t squared, and then these are a, b, and c. These are undetermined coefficients. You have here 2t, okay, this is bt, and then 5, we have here c equivalent. And then we also have 2t, we have here bt, and then 2 is constant c, and then we have all this value, 2 and 0, so it follows here letter c, unknown, undetermined coefficient. So we have our y sub p for this case, which is equivalent to a times t squared plus bt plus c. So this is now our undetermined coefficient. So since this is second derivative, so we will take the derivative of our y sub p up to the second derivative. If this is third derivative, then we will take the third derivative of y sub p. Since this is only a second derivative, so we will take the derivative of y sub p up to second derivative. Okay, so again, I will write y sub p from this part. Y sub p, which is equivalent to a times t squared plus bt plus c. And then y sub p prime, that is the first derivative, which is equivalent to 2a times t, 2a times t plus b. And then second derivative of y sub p, which is equivalent to 2a. This time, after we have here up to second derivative, we take the second derivative of y sub p, we will go back to this equation. Okay, so we will write here 2y double prime minus y prime minus y is equivalent to t squared plus 2t plus 5. But this time, instead of writing y, we will make use of p for this part, so y sub p. Substitute all values of y to y sub p. Then we have here y sub p, then we have here y sub p. And then this time, we will substitute the value of your y double prime p. So let's say this is our step 3. Step C. So 2 times, instead of writing y double prime p, we will make use of its equivalent, which is 2a. So we have here 2a minus y sub p prime, the first derivative we have here, that is 2at plus b. So minus 2at plus b. Next, minus y sub p. Y sub p is this one, the equivalent of y sub p. You have here a t squared plus b t plus c, which is equivalent to this one, that is t squared plus 2t plus 5. This time, if you look at this one, the highest exponent of t is squared, so we will write t squared here. All variables with t squared, we will write this one, no t squared, this one is t squared, so that is negative a. And then on the other side, that is 1. Okay, 1, sorry. I will write here again. So this is 1. the numerical coefficient for t squared is 1, so we write here 1. Therefore, if you have noticed a, we find the value of a here as equal to 1. Next, t squared, so t, the next highest exponent for t is t raised to 1. So all variables with t, we have here negative 2a. Negative 2a. And then with t, we have here negative times positive, that is negative b. And then we have here 2, so equals 2. So if a equals 1, then negative 2a, if we substitute a as 1, so that is negative 2 times 1 minus b is equal to 2. So that b, we transfer b to the other side, that becomes positive, and then this one in this side, so negative 2 minus 2, that is negative 4. Therefore, b equals negative 4. We will check. Negative 2 minus 2 is equal to b. This 2 transfer to the other side, that becomes negative, and then b to the other side, that becomes positive. So this is the equivalent. B equals negative 4. Okay, from that equation, we found out that b equals negative 4. Okay, next. Once we find the value of a and b, this time proceed. T raised to 2, t raised to 1, t raised to 0. Or in other words, these are just a numerical value or coefficient without t. So this one, there's no t. So 4a. And then the other one, that is negative b. And then c, negative c. Negative c. And then on this side, we have 5 equals 5. Okay. So let me check 2a and then b. Okay. So if we have here 4a minus b minus c, substitute the value of a. Okay. So by the way, we have here a negative a equals 1. So actually this one is negative 1. Negative 1. Supposed to be negative 1. So if this is negative 1, then this is also negative 1. So I have an error for this part. Okay. So this is supposed to be negative 1. Oh, I will erase. I will check it again. Okay. So we have negative 2 times a, that is negative 1. Substituting the value of a minus b is equal to 2. So this is negative 2 times negative 1, that is positive 2. And then negative b on the other side, so we have here negative 2 times negative 1 minus 2 equals b. We will transfer b to the other side and then 2 on the other side. So this is now negative 2 times negative 1 is positive 2 minus 2 equals b. Therefore, b is equal to 0. So this case, in this part, b is equal to 0. Okay. I will erase now this part. Okay. So we go back to this equation. For a, that is negative 1. So when we substitute the value of a as negative 1, so 4 times negative 1 minus b, that is 0, minus c is equal to 5. So we will transfer c to the other side. This one now is 4 times negative 1 equals negative 4. And then b, 5 to the other side, that becomes 5, which is equivalent to c. So c is equivalent to negative 9 for this case. Therefore, c is equal to negative 9 for this case. So we have our a, b, and c. So b is 0 already. So this time we will erase this one. So when we solve problems like this one, of course, after we find the value of the undetermined coefficient a, b, and c, of course, we go back to our y sub p by substituting all the value of a, b, and c. So our y sub p, for this case, we have here a t squared. Our a equals negative 1, so that is now negative t squared. A equals negative 1 for this case, so negative 1 times t squared, that is negative t squared. And then b, times t, b is equivalent to 0. Therefore, we will no longer include bt. And then plus c. The value of c here is negative 9. So, negative 9. Therefore, our final solution y is equivalent to y sub c. Okay, y sub c. I will erase this one. Okay, y sub c plus y sub b, which is then equivalent to our y sub c. Based from this value, we have c sub 1 e to the t plus c sub 2 e raised to negative 1/2 of t. And then y sub b minus t squared minus 9. This will be our final answer. Another example, we have solve the equation d squared plus d minus 2y equals 2x minus 40 cosine of 4x. So we have here our differential operators. So to solve this problem, again, we will write its auxiliary equation. So we have, this is second derivative. So m squared plus m minus 2 is equivalent to 0. And then we will factor this one. This is equivalent to m times plus m plus 2 times m minus 1. So you can make use of your calculator or you can make use of synthetic division. So this one, I am factoring m plus 2, m minus 1. So 2 times negative 1 equals negative 2. And then when we add to a negative 1, that is equivalent to 1. Therefore, our m here is equivalent to, we have m plus 2 equals 0. So that is negative 2. The other one for m minus 1 equals 0. So m is equivalent to 1. So we will make this one as our m sub 1 and then this one as our m sub 2. Therefore, our y sub c or the complementary function, that is now equivalent to, again, this is an auxiliary equation with distinct roots. Therefore, we have c sub 1 e raised to, this one is negative 2x. Okay, negative 2x plus c sub 2 e raised to, this is 1 times x, that is raised to x. So this is now our complementary function. Next to that is, of course, we have this one. We have to take the derivative of this function. Okay, we have to take the derivative of this function. So we have 2x 2x minus 40 cosine of 2x. And then the derivative equals 2 minus derivative of cosine is negative sign. So this will become plus 2 times 40, that is 80 sine of 2x. And then the derivative of this one, that is 0. Derivative of sine 2x equals cosine times 2x. So this is equivalent to 160 cosine of 2x. And then the derivative of cosine 2x equals sine 2x times 2. So negative 130. I mean, okay, 160 times 2, 0, 2 times 6, 12, carry 1, 2 times 2, 320. So this is 320. Okay. 320 sine 2x. So if you have noticed, we have to make our undetermined coefficient that must be contained with ax, and then we have here a constant. So we have a plus ax, bx plus cosine and sine. So c cosine 2x, and then plus d sine 2x. Okay, I will write here I will write here this one. I will transfer it here. So a plus bx plus c cosine of 2x plus d sine 2x. Okay, I'll just transfer this one here. So this will be our y sub p. Okay, so I will erase this now. So you have to make sure that all the variables here, okay, or let's say the term here must be found here in your y sub p. For example, this one 2x. Okay, if that is 2x, so it must be found here in bx. This 2 is a constant, so you have here your a as a constant. And then we have sine of x, sine 2x, so we have here sine 2x, and then this one is d, constant. And then cosine 2x, we have here cosine 2x, and then c. Okay, so this is our y sub p. Since this one is up to second derivative, our problem is up to second derivative, then we have to take the second derivative of our y sub p. Okay, so we have y sub p, first derivative. Okay, first derivative of this one, we have b plus derivative of cosine is negative sine 2 times c, so that is negative. I will erase this one. Negative 2 negative 2c sine of 2x. So that is the derivative of c cosine 2x, that is negative 2 sine 2x times c. And then this one, derivative of sine 2x equals cosine 2x times 2. So plus 2d cosine 2x. That is our y sub prime, y sub p prime. So first derivative, this time second derivative. So we have y double prime of p, which is equivalent to this one becomes 0. So the derivative of sine equals cosine 2 times 2, 4. So negative 4c cosine of 2x. And then this one derivative cosine, derivative of cosine is negative sine. So negative 4d sine of 2x. So this time we go back to our initial equation. Rewriting our initial equation, this is now y double prime. Okay, this is our y prime, second derivative, first derivative, and then 2. Okay, again, the second derivative, first derivative, and then 2 times y. So we have y double prime plus, that is the second derivative, y prime, that is the first derivative, minus 2y, that is equivalent to 2x minus 40 cosine of 2x. We have this one. So instead of writing y, we will make use of p. So I will write it here. This one, that is negative 4c, cosine of 2x minus 4d sine of 2x. That is our, we will make this one as our p, and then p, second derivative. Okay, this is based on this equation. Take note. Okay, and then instead of writing y sub y, we will make use of y sub p. Okay, this is the second derivative. This time the first derivative, we'll make use of this one, plus b minus 2c sine of 2x plus 2d cosine of 2x. That is our first derivative, b minus 2c sine 2x, 2d cosine 2x. Then this time we have here the negative 2y sub p. I will write it here. negative 2 y sub p. Our y sub p, we have here a, and then plus bx plus c cosine 2x plus d sine 2x. That is our y sub p. And then that is equivalent to this one, 2x minus 40 cosine 2x. Okay, this time we will now determine the undetermined coefficient a, b, c, d. So you notice we have here cosine, so we will start with cosine, all terms with cosine. So cosine 2x. So we have here negative 4c. And then the other one, cosine, that is 2d plus 2d. And then cosine here, this is c, negative 2c minus 2c. And then we have here negative 40 equals negative 40. That is negative 40. Okay, so this can be write as 2d minus 6c, which is equivalent to negative 40. Okay, this time those variable, I mean terms with sine 2x, we have negative 4d with sine 2x, negative 2c, and then we have here d, negative 2d, and then sine, that is 0. Okay, so this can be rewrite as negative 6d minus 2c is equal to 0. Okay, that is now the... So sine, cosine, this time with x only, with x. Okay, we will look at terms with x only, so negative 2b. So negative 2b, and then equals 2. Okay, which is equivalent to 2. So for this case, b equals negative 1. That is 2 divided by negative 2. That is negative 1. Okay, this time with x sub 0, or those with numbers only without variable x. So for this case, this is negative 2a. Negative 2a. And then what else? Okay, there's no other variable or term, so which is equivalent to 0. Therefore, for this part, our a is equivalent to 0. Once we have the value of a and b, we have to find the value of c and d. Okay, so for this part, we have here d and c. So we will combine these two equations. So to combine these two equations, of course, we have to multiply. We want to eliminate one of its variables. So for this part, we will multiply it by 3 so that we will eliminate d. Okay, so I will multiply this equation by 3. So that is equivalent to times 3, that is 60, minus 6 times 3, 18c. And then equals 40 times 3, that is negative 120. This one, it will retain as negative 6d minus 2c, which is equivalent to 0. And then we will add these two equations. We eliminate d. So when we add, that is 20, negative 20c, equals negative 120. Therefore, c is equivalent to 120 over 20 equals 6. We have now the value of c. If c equals 6, then we substitute to this equation. So if c equals 6, so we have 2d minus 6 times 6 equals negative 40. Okay, I will make use of the other equation. I will make use of other equation. The other one, we have this one. So, negative 6 times d minus 2 times c, which is 6, is equal to 0. So, for this case, our d is equivalent to 6d, 2 times 6, 12, positive 12 divided by negative 6 equals negative 2. So, we have the value of our d, the value of our c, the value of our b, and then the value of our a. Okay, so we have 4 values. So we have the value of a, b, c, and d. So we have to check first our a. This is equivalent to 0. Okay, so we have okay, we have our y equals y sub p. Therefore, we will substitute y sub p. Okay, which is equivalent to a. We do not have the value of a, so it will remain as 0. And then bx, our b equals negative x, this one, plus c. Our c is 6 cosine of 2x, plus d, we have negative 2, so this is negative 2, negative 2, our d equals negative 2 sine of 2x. Therefore, our y is equivalent to y sub c. We have here as our y sub c. Okay, I will transfer this one first. Okay. Okay. So, we have y sub c, which is c sub 1, e raised to negative 2x plus c sub 2, e raised to x, and then our y sub p, that is negative x, and then plus 6 cosine 2x minus 2 sine 2x. By the way, we have here for our x sub o, we have here b minus 2a. So we're supposed to have here b minus 2a. Okay. B minus 2a. So this is a correction. B minus 2a. So I will erase this one. Is not equal to 0. B minus 2a. So if b is equal to negative 1, and then a transferred to the other side, that becomes 2a. Therefore, a equals negative 1 half. So we still have to insert a as 1 half here. Our a here is, we have 1 half. Negative, we're supposed to have here as 1 half. Therefore, we have to insert here as 1 half. Negative 1 half minus x. So negative 1 half minus x. Okay. So this will be our final answer.